Okay, make a little couple videos here to do some 10.4 homework. So this is question 3. Find the value of a retirement savings account paying an APR of 5.5% compounded monthly after 35 years of monthly contributions. Contributions made at the end of each month, including the last month, when the monthly contribution is shown. Okay, so let's do part A first. If the monthly contribution is $115. So before I can do anything, I have to figure out which formula to use. So I have copied in the financial formulas flowchart from your packet right here. It's really tiny. I'll make it bigger for a few minutes while we talk about it. Okay, so let's see. We are saving, right? This is a retirement savings account. So we go down the savings branch. Are we making multiple investments at regular intervals or a single investment of one chunk of money? Well, we're doing monthly contributions. So that is multiple investments at regular intervals. So this is the formula we're going to be using. So we're going to write that down before we start work on anything else. So let's see, we've got F for future value is M for your monthly contribution times, let's move this out of the way, 1 plus R over N to the N T minus 1 divided by R over N. Okay, and then it tells you what all the letters stand for down here. So F stands for future value. P is present value or principal, but that's not in this formula. M is the payment or deposit amount. So it's typically called M because monthly is the most common way that you make payments or receive payments. And then R is for APR, interest rate, T in time, N for number of compoundings per year. Okay, so we have future value is equal to M, your monthly amount, $115, times 1 plus my APR, or little r, is 5.5%, but we're supposed to write that as a decimal. Okay, so it should be 0.055. Over N. And N is the number of compoundings per year. And because we are compounding monthly, that means 12 compoundings per year. So to divide that by 12. Raise all of that to the NT. So that's N is 12 and T is time, and that's 35 years. Then minus 1 all over R over N. So R, 0.055 divided by N, which is 12. Okay, so now it's a matter of doing this on the calculator. So future value equals, so I've got my calculator here. I am going to start by doing the 0.055 divided by 12. Because the order of operations says that you should do things that are in the parentheses first. So I've got parentheses here. And then within the parentheses, you should do the division before you do the addition. So I do 0.055 divided by 12, and I get 0.004583333. It's not a nice number. So I think I'll store that as the letter A. So store as the letter A. Different calculators do that differently. There's a couple videos in my playlist on how to do that. All right, so then we've got 115 times 1 plus A, because I stored that 0.055 over 12 as the letter A. All right, 12 times 35, I can do that. That's 420 minus 1 all over the letter A. Okay, so now in my calculator, I'm going to type 1 plus A, And I get like 1.004583333. All right, and then I'm going to raise that to the 420 power. Move this out of the way. Okay, so raise to the 420, and I get 6.825. I'm going to subtract 1. So I'm not writing anything down because I don't want to round anything. So I just hit -1. I'm not retyping the number, just hit -1 from the 6.825065751, and you get 5.825. Okay, so I'll write that down. 5.825 ... lots more decimals, divided by A. Okay, so I wrote it down just so that we don't lose track of what you're supposed to have on your calculator screen. But I'm not going to retype 5.825. It's already on my calculator screen from my previous answer. And I'm just going to hit divided by, and I'm going to type the letter A, divided by A. And I get about 1270.92, more decimals that I'm not writing down. But in my calculator, I'm keeping them all. Okay, so now I have 0.923437 in my calculator as the decimal. I'm going to take that whole thing. So rather than retype it, just hit times 115, and we get 146.19. This is the future value of your retirement account. Okay, so I'm not going to go through B and C. The process is the same. You're just going to replace, you're going to do the same process, but instead of 115 here, you're going to have a 5150 and a 140. Okay, so you don't actually have to go through all of these steps again. You can just use this final number, multiply it by 5150 and multiply it by 140, and you'll get the future value for those two accounts. So for this one, we're supposed to find the value of a retirement savings account that has a monthly contribution of $100 and an APR of 5.5% compounded monthly after 40 years, 55 years. Okay, so I'm using the same formula as before. This is multiple investments made at regular intervals in a savings account. So we land at this formula. Let's copy it down. F equals M times 1 plus R over N to the NT minus 1 divided by R over N. Okay, and now in this case, M is 100. Interest rate is 5.5%, so 0.055 divided by 12 because we're compounding monthly. Raised to the 12 times 40, because 40 years, divided by 0.055 over 12. So now this is just a matter of typing it into our calculator appropriately. So same as before, 0.055 divided by 12 is stored as the letter A. Okay, so I'm going to do 1 plus A, and then raise that to the 12 times 40. And I get about 8.97. Then I need to divide that by A. And I get about 1959.22. So this is 100 times 1959.22. Lots more decimals. I haven't rounded anything as I've been going along here. And now I just need to multiply that times 100. And I get 195,000. $922.14. Okay, so I'm not going to go through parts B and C. It's the same style problem. You're just going to be replacing, instead of T being a 40, you're going to put in these different time amounts, 55 and 57.5. The last one, what should your monthly contribution be if your goal is to have $270,000 in your retirement savings account after 11 years? Interest rate is 8.25%, compounded monthly, and that contributions are made at the end of each month. Okay, so if we're making monthly contributions, then we're using the same formula as the previous two problems. Multiple investments at regular intervals. So let's copy that formula down. Okay, now the question is, what should your monthly contribution be? So we're going to be solving for M. We want to have 270,000. That's our future value. We want 270,000 to be the future value of the account. We want to know what M needs to be. And now I should be able to plug in all the other numbers here. So I have 1 plus, R is 8.25, so 0.0825, over N, the number of compoundings, which they told us it's compounded monthly, so that's a 12, times, raised to the 12 times 11 years, divided by 0.0825 over 12. Okay, so 270,000 is equal to M times a number. Okay, we just have to calculate what this number is. So I have 0.0825 divided by 12. I'm going to do that first, and that's 0.006875. So I'm going to add 1 to that. Actually, I'm just going to write it down. 1 plus 0.006875 raised to the 12 times 11, which is 132, divided by, oh, I forgot the minus 1, divided by 0.006875. Okay, 270,000 equals M times, okay, 1 plus 0.006875 is 1.006875. Raise that to the 132 power, then subtract 1, then divide by 0.006875, and we get 213.88161444, not rounding anything until the very end. Okay, so next I'm going to divide both sides by this 213 number. Okay, so on the right, those cancel and we get M. And on the left, we do 270,000 divided by the 213 number. And I get 1,262.38. So your monthly contribution would have to be $1,262.38.